to be talking about graphing polynomial functions. This is day one. We actually won't be graphing any polynomials today, but we will be talking about polynomials and classifying them and their end behavior. All right. So what I have here first is a chart of how to classify polynomials, okay? It gives us the degree, the type, how to write it in standard form, and an example. So let's actually read this from left to right. We have an example, and is negative 14. Any number, negative 14, 5, a million, is what we call a constant, and the degree for this is a 0, because we do not have a variable, so the degree is 0. For the second one, 5x minus 7, the highest degree is 1, so it is linear. The next one, the highest degree is 2, so that's quadratic. The third one is 3, cubic, and the fourth one is 4, quartic. Now, there are a few things that are not a polynomial. One is when the degree is negative, like x equals negative 1, and then also can be rewritten as 1 over x. So if we have a variable in denominator, it's not a polynomial either. And another example is if x is an exponent. So if we have 2 to the x, that is not a polynomial either. So those are two that you have to look for to see if it's a polynomial or not. So we're going to use this chart and this information to answer some questions about polynomials. So this says, decide whether each function is a polynomial function. If so, write it in standard form and state its degree, type, and leading coefficient. And standard form is when you take your highest degree and go to your lowest degree, and your constant is at the very end. So for number 1, this one is a polynomial, and it is in standard form, so we don't have to rewrite it. The highest degree is 3, so it is a cubic, and the leading coefficient is negative 2. For number 2, I see a negative exponent, and if I have a negative exponent, this is not a polynomial. Number 3, I notice that my highest degree is a 4, but this is not in standard form because it's not in decreasing order. So I'm going to rewrite this as the g of x is equal to the square root of 2, x to the 4th, minus 0.8 x to the 3rd, minus 12. Now that it is in standard form because it's in decreasing order. The highest degree for this one is a 4, so it is a quartic. And the leading coefficient for this one is the square root of 2. Number 4, if I look very closely, I have a variable as an exponent, so this one is not a polynomial. All right, next up is evaluating a function for the given value of x. Well, for number 1, I give you the value of x as negative 7. When we are in function form, we have to make sure we have proper notation. So when we write this, we say the f, and instead of x, we say negative 7. That tells us every time we see an x, we're going to plug in a negative 7. So we're going to write this as 7 times negative 7 to the 4th, minus 10 times negative 7 to the 2nd, plus 14 times negative 7, minus 26. We may use our calculators to evaluate this, and our final answer will be f to the f of negative 7 is equal to 16,193. And that is going to be our final answer with the correct notation in function form. The next one is going to be the h of negative 1/3. So we're going to plug that into our function. And make sure when you plug this into your calculator, you're being very careful with your parentheses and your positives and negatives. If you are coming up with the wrong answer, you can evaluate each term by itself and then combine at the end. And sometimes that can help your mistakes, help not have so many mistakes. So the final answer for this one is the h of negative 1/3. is going to be 76 over 27. And like I said, if you get the wrong answer, go back and evaluate each one of these separately. Do not put them into decimal form. You may get a wrong answer. If you start with a fraction, you end with a fraction. All right, next up, we're going to be talking about end behavior. I took this directly out of your book, so you can look at it in your book. But the end behavior is where the x and y values are going at the ends of the graph. So if you look at this first one, right here, the y values are going positive, or we call it the f of x. The y values are being positive, so the f of x approaches positive infinity, and the x values are also approaching positive infinity. And if we go and look at the left end, the y values are approaching negative infinity as the x values are approaching negative infinity. So that's how you read those. And if we look at this, we can take a look at a polynomial and to determine if the degree is odd or even, and if the leading coefficient is positive or negative. And determining these two pieces of information will tell us what the end behavior is. So we're going to look at the polynomial, determine if it's an even or odd, or positive or negative, and then we're going to go back to our chart, and that will tell us our end behavior. So let's take a look at these. If we look at the first one, the highest degree is 7. So our degree is odd, and our leading coefficient is positive. So we're going to go back to this chart and we're going to look for odd positive, and that's our first one. So our end behavior are these two pieces of information. So we're going to take those pieces of information and write them down. So as the g of x, because we're starting with g of x, we say g of x approaches positive infinity. Oops, that's an 8. As x approaches positive infinity. And then g of x approaches negative infinity as x approaches negative infinity. And that's your end behavior of this graph. Now this is going to help us in tomorrow's lesson actually graphing polynomials, and that's where it leads to. So if we look at number 2, the highest degree is 5, so our degree is odd, and our leading coefficient is negative. So we're going to look for odd and negative. So it's going to be these two pieces of information, and we're going to write them down. So let's start off with f of x, because we have an f. F of x approaches positive infinity as x approaches negative infinity. And then f of x approaches negative infinity as x approaches positive infinity. So that's how you determine the end behavior of these polynomials, and this information will help us graph our polynomials tomorrow. What we also can do is we can go the reverse. We can describe the degree and leading coefficient of the polynomial using the graph below. So we can take a look at its end behavior. Let me put this one in the middle. Let's scoot this over. We can determine the end behavior, and then that will tell us what the degree and the leading coefficient is going to be. So it'll tell us degree and leading coefficient. So let's look at the end behavior. So on this side, the f of x is approaching positive infinity as x approaches negative infinity, because this is going positive and this side is negative. Okay? And on the other side, f of x is approaching positive infinity as x is approaching positive infinity. So we go positive y, positive x. So what we're going to do is we're going to look for this end behavior and see what it matches up with. So let's go back to our chart. Okay, and we're going to be looking for positive f of x approaches positive as x approaches negative, and f of x approaches positive as x approaches positive. And that's going to be this one down here. So our degree is even, and our leading coefficient is positive. So let's go back. So the degree is even, and the leading coefficient is positive. So we can go either way. We can read the end behavior and determine the degree and leading coefficient from a graph, or from the polynomial, we can determine the degree and leading coefficient to figure out the end behavior.